Hello all. So we are going to continue our elementary algebra online. So you will be able to find all of the videos regarding our class and lectures on my YouTube channel, and I will be posting in Canvas notes and announcements and everything else as we go on. So we're left with two sections in chapter 4, and then we are going to have at some point an exam on MyMATLAB. We'll talk about that later. So let's deal with 4.1. Solving systems of linear equations. So, as we discussed in the class, but this is going to be the lecture from scratch, system of equations is going to be when you have two linear equations coupled together with the same x and the same y, and your goal is to determine the value for x and y so that you can find the solution. Now, first, let's just write the system. Would look like, let's say, ax plus by equals c, and then dx plus ey equals, let's say, f. So that will be a system. So two equations with the two unknown variables. So a, b, c, d, e, and f are constants, and x and the y are variables. Goal: to solve the system. So goal is to solve the system, and in order to solve the system, we are trying to find so goal is to solve the system, and in order for us to solve the system, we are looking for three possible types of solution. So one solution, which is xy, no solution, or infinite solution. So we are going to take a look at these three cases. Oops, why is this like that? Give me 1 second. That's better. Let's see if that, I'm not sure why is that in the middle of the screen. It's supposed to be in a corner. Anyway, so now we have ways to solve this. Number 1, which is in 4.1, graphically. And number 2, in 4.2, substitution. There are more ways, but they are for later courses. So now we are going to talk about solving the system's graphical solution. So for the graphical solution, we will have to use the square grid in order for all of these equations to be properly displayed and the solution to be properly displayed so you can read it off of the graph. So let's say we have two equations and we want to see if they have a solution somewhere. So let's say you want to graph an equation, so solve the system. And now we're going to have two equations given to us. So let's say x plus 2y equals 4 and 2x minus y equals to 3. So our job is to graph these two on the same coordinate plane, and wherever they intersect, it's going to be the solution of the system, because they intersect at the point xy, right? X value is given by a number, y value given by a number, and that will be a solution. So we are going to now graph these two equations. Now, the way we graph is, this is standard form. In chapter 3 we learned that we should look for xy intercepts real quick. So when x is 0, x goes away, and then when you divide both sides by 2, we have that y is 2. Similarly, when y is equal to 0, then y goes away, so x is 4. And now we have x and y intercepts to graph. So we draw xy plane. I'm just going to steal it from the menu over here. We label our axes y and x. Then we graph y-intercept of 2 and the x-intercept at 4. And we connect those with the straight line. Then we go and look at the other equation, which is going to give us again x and y intercepts because it's in the standard form. When x is 0, that goes away, so y is negative 3, because the y is y negative, y divide both sides by negative. When you divide both sides by negative 1, you will get negative 3. Next, so that's here. And when we draw the line, we see that they intersect at this one point here, and that one point there is our xy, which is given as, we can read it, 3, 1. So 3, 1 is a solution. It is one solution because we got only 1 point. For that solution, x is equal to 3, y is equal to 1. Very important when you do these problems is to check, because it is very easy to make mistakes here, especially if you're not drawing these things precisely. You can read the wrong point off of the graph. And right now I'm seeing that I made a mistake. This is supposed to be 2, 1. Not 3, 1. 2, 1. 2, 1. So now, to check, we plug this point 2, 1 into the original equations, right? So we have x plus 2y equals 4, x equals 2, y equals 1, plug in. So x equals to 2, plus 2 times y is 1 is equal to 4. We are asking ourselves if that's true. So 2 plus 2, is that 4? Yes. 4 equals to 4. So that checks out. Now we have to do one more. That's 2x minus y equals to 3 is the second equation. So we have 2 times 2 minus 1, is that 3? Yes, because 4 minus 1 is 3. 3 equals 3. Over here, right, we still have x equals to 2, y equals 1, plug in to check. So because both equations checked out, we know that 2, 1 is a solution. So 2, 1 is correct because it worked in both equations. And we can have 3 types of solutions. As we've seen before, we can have one solution, which is the example we just had. We can have no solution, and we can have infinitely many solutions. So now, when we are solving problems by graphing, we have intersection, number 1. And that's one solution, which is x comma y. Then we can have no solution. Lines are parallel. They do not intersect. They do not cross. And because of that, they don't intersect and they don't cross. Because of that, we have no solution. And number 3, infinite solution. Which is same line. Because when 2 lines are the same line, they intersect at every point. That's infinitely many points. So therefore, infinitely many solutions. So let's take a look at some examples of this. Say you have a system that is y equals 2/3 x plus 1 and y equals 2/3 x minus 4. So this would be a situation when the system has no solution because the lines are parallel. Now, how do we know the lines are parallel? In the previous chapter, we learned that parallel lines have the same slope, right? So these are clearly not the same lines because 1 and -4 are not the same number, but they have the same slope. So we can see that these are parallel immediately because the slope is the same. And we can just say lines are parallel, no solution. But we can also graph it and show this case. So let's go and graph this real quick. So we're going to put a system right here. That should be good enough. And graph these. So the top line, we can call that line. You know what? We can actually, what we can do is we can color code them, right? So this could be blue, and the other one could be red. There we go. So let's go with the blue equation first. This is our y, this is our x. For our blue equation, the y-intercept is 1. We go 2 up, 3 over. And we draw our blue line. The line is going to go forever. Then we're going to take a look at our red line, which is at -4. This one was at 1. Wait a minute a second. There we go. So, -4, we still go 2 up, 3 over, and draw the line. What we see is that two lines are parallel, and because the lines are parallel, they never intersect, and because of that, there is no solution. So the two lines are parallel, therefore they do not intersect, so there is no solution in this case. So when the two lines are parallel, they cannot intersect. Since intersection is a solution and there is no intersection, then there is no solution. So in this case, no solution. The last case is where two lines are the same line. And when two lines are the same line, then there we have infinitely many solutions. So let's say you have y equals, I want to do 2/3 again. Let's go with 1/2 x plus 2. So that. And then let's say we're going to have x minus 2y equals to -4. So this system should have infinitely many solutions because these two lines should be the same line. Well, let's check. The top line is our easy counting line. Oh, let's go again with the red and blue. Put that, let's say, red. And put the second one over here, blue. All right, so now what we know for the second equation, the blue equation, it's in the form where we get to do our x and y intercept chart. 0, 0. So we are going to go and use x is 0, that kills of x, right? So -4 divided by -2 is +2. And then when y is equal to 0, it kills of y, x is -4. So the red equation is easy to graph because we just do counting. And the blue equation is the one that it's given as a standard form where we do x and y intercept, which is the chart on the side. So now all we need to do is to graph these, and we see if they intersect at one point, if they're parallel, or if they are the same line. Now, as I said, this should work out to be the same line. Oops, I didn't want this to be blue. Can I change it now? Yes. Okay. So let's go and put, remember that you are supposed to put x and a y first. So y-axis and x-axis. Now, red equation. Start at 2, go 1 up, 2 over, and draw the line. So that's the red equation, and it's infinite. And now the blue equation, we do have, for the blue equation, we have intersect points. So we have a 2 and -4. Look at that. Same line. So, same line. And if it's the same line, that means infinite number of solutions, because they intersect at every point and there are infinitely many points all clumped next to each other. Therefore, that's what we have. So you have seen all 3 possibilities. You have to be able to graph both types of equations. The one where we have a slope-intercept form, and for the slope-intercept form, we do the counting. So we first graph the y-intercept, and then we count the slope for the second point. And when you have a standard form, you have to do the xy-intercept chart, and then plot those 2 points, and then draw the line to them. So you have to know how to graph both types of the lines. And over here you have 3 examples. Each example shows you different situation. When you have one solution, when you have no solution when they're parallel, and finally when you have infinitely many solutions when it's the same line. And that wraps 4.1. The homework will be posted on my MATLAB. I will return with 4.2 to end the chapter. Bye.